So just a quick intro and welcome back for those that joined us at 9 for the first of our lectures for today. If you're just joining us, slightly different setup to what was planned for face-to-face. We've shifted online just based on needs and what works best for our members. So this is lecture 2 or kind of series 2 of our spring lecture today. I'll shortly do an intro of Tony and what we're about to hear from. But just a similar setup before. Obviously, shortly I'll hand over, then we'll hear from Tony. Potentially 45 minutes of a presentation, and then the tail end we'll have an opportunity for Q&A. So by all means, forward any questions you've got during the session, or kind of save them to the end and post them through. 2 ways to send them through: either use the chat functionality and just direct it towards the panelists and I'll be able to pick them up, or there's also Q&A functionality in Zoom, so you can also log your question there. And what I'll do is I'll queue them up, and then once Tony's finished from a presentation point of view, I'll field your questions on your behalf. So quick intro, first of all, to Tony, and then I'll introduce what we're about to hear from, and then we'll get started. So Tony, first of all, Tony Costa from OpenVault. So Tony leads OpenVault product management, development, operations and support organizations, and oversees its technology infrastructure. With over 25 years in leadership roles across product management, technology operations and business development, Tony has brought to market a number of industry first products, from startup incubation to leading companies in telecoms, media and technology industries, including Vodafone, T-Mobile, Alcatel-Lucent, Real Networks, Cineverse, Ventrac, and We Do Technologies. Tony has several patents related to communications techniques and network optimization. Tony's presentation shortly, titled Automated Upstream Bandwidth Maximisation with Profile Management Application During COVID and Beyond. That's a mouthful. And a short abstract about what we'll hear from. The unprecedented growth in broadband users and usage due to COVID-related changes in behaviour, such as peak, off-peak usage, and the adoption of applications and connected devices that consume significantly more network resources, especially in the upstream, have introduced significant challenges and constraints across access networks. Operators have typically alleviated these situations through additional capital expenditures. This session highlights a more cost-effective, dynamic and automated long-term options for operators, which is available across all current and future DOCSIS compliant networks. Profile management application. Tony, the floor is yours.
All right. Thank you, James. For a second, I didn't think you were talking about me. Much appreciated. So I also like to thank the CT for the opportunity, and also Melissa for facilitating all this, the changes in planning and making arrangements so that it all goes accordingly. Started. Just a little bit about OpenVault. We provide broadband solutions to operators worldwide. These solutions are based on big data analytics combined with machine learning and automation, either closed loop or open loop automation. We differentiate those because in some cases it's important to provide operators with insights into what's going on in the network, and in other scenarios operators would like to also take prescriptive actions related to the findings or the real-time activity in their networks in order to remediate situations or to improve performance. As part of this offering, we track a significant amount of usage across our customers. We anonymize the data, aggregate it, and then we analyze that information for our customers and also in overall industry insights. We use some of that information to publish a quarterly report, which is called the OpenVault Broadband Insights report, and where we consolidate some of the findings across the globe. In some cases, we try to consolidate that into particular regions, but it provides very insightful information, not only for the broadband industry, but we are finding that also some analysts and media outlets, as well as other enterprises trying to get into the broadband space, find that data very interesting. So some of the information I'm going to present was derived from those quarterly OVVI reports, in addition to some of the capabilities that we have in our solutions. So one surprising element that we discovered in the latest OVVI, the fourth quarter 2021 OVVI, is that the average usage per subscriber finally crossed the half of a terabyte threshold. So the average usage in that quarter was 536 gigabytes, which is quite significant. And I'll show you a little bit more in that trend, about that trend in some subsequent slides. This increase in usage also was combined with increase in overall speed adoption, so service plan adoption, different speed packages. And these increases in speed packages are related to some of the behavior of the subscribers. We're finding the subscribers have more and more connected devices in the home. The connected devices have more and more high quality streaming capabilities or quality video capabilities, for example, and some of those devices actually leverage the adaptive capabilities of transmission that are enabled through the increase in speed, which then result in higher usage. So they're all intertwined. But this increase in usage, some of it for sure is related to COVID and pandemic and the change in behavior during those times where subscribers either worked from home or studied from home, and we're finding that that is the case. But also, I think there's a change in culturally also in how people use broadband. And related to that, there's been some analysis published by Barron's where they think the current environment for the workplace is stabilized in 3 different sectors. Somewhat obvious, I guess, depending on which company you work for. For example, we have companies in the US where it's very common for the employees to go in once a week or 3 times a week. So this would be the 40% hybrid category in the center that Barron's identified. There are companies that are mandated that everyone go back into the office, and the banking industry and some of the larger banks in New York City are mandating that. And then there are some industries where the remote work is actually perhaps just as efficient as being in the office. So 50% of the workforce is expected, from now and long term to be in the office full time, but then you have the 10% that'll be remote. So that combination introduces some new usage patterns in broadband, both downstream and upstream, and then more importantly on the upstream direction, because it's a more limited resource in cable DOCSIS. The traditional use for cable was more downstream heavy, so most content flowing to the subscriber as opposed to the subscriber being the publisher. And we now are in a world where video transmission is becoming more and more prevalent, and subscribers are to some extent becoming publishers of content. And even as we speak, I am sort of a publisher in the sense that I'm transmitting video upstream via the webinar. So there's more and more of this activity, including all the different video conferencing services, content, social media channels. All of that is generating more and more usage, which results in some new patterns and some new classifications on what is a heavy user, power user versus a traditional subscriber. So power user for us, and the way we analyze it across our various reports, is someone who's considered to consume more than a terabyte or more per month. And we've now started to introduce a secondary category, which is 2 terabytes. But if you look at the 1 terabyte per month or more power user base, In 2017, that represented 2% of the subscriber base. This latest report, the fourth quarter 2021 report, the power user base represents 16% of the subscribers. So subscribers consuming more than 1 terabyte has grown significantly, an increase of 8 times in a span of 5 years, more or less. And we don't think it's going to stop anytime soon. In fact, we've seen users, some customers in the 10, 20 terabyte a month power usage category, which we haven't even classified yet. But there are some anomalies in the usage, but the trend seems to be that it's going to continue to grow. And the growth is due to a variety of services, adoption, as I said, of streaming services and higher quality services, and also services that automatically take advantage of the available capacity. So if we look at this power usage and the growth in general of data consumption over the last 5 years, you see in 2017, our power usage category might have been only 256 gigabytes, where now we're into the terabyte, but the increase is significant. So over 5 years, we're over almost 3 times the usage consumption per month on an average on a monthly basis. So this is a trend that is likely not to stop, as is the evolution of the other categories. So the high usage base is growing, as is illustrated in this trending view. So we see that over the 5 years, the power usage category, 1 terabyte, 2 terabyte and beyond subscriber base has grown by 20%, where the low usage base, subscribers using less than 100 gigabyte, has decreased by 48%. So there's a clear trend on usage growing at a significant pace, and being not limited by necessarily what subscribers are doing. So, the behavior of the subscribers, in some cases, it's more limited by what's happening in the network in terms of congestion capacity. Because as these services are consumed by concurrent users in the shared space of cable services, the available capacity is consumed very quickly, and there aren't many alternatives available to operators until recently that they could use to remediate, except for capital expenditure. So we're finding that some of the tools that we've introduced help operators not only manage that capacity, the demand on capacity, and also give them some headroom to increase the capacity and handle the trend in additional usage. So the usage trend is interesting, as is the adoption of the speeds and the adoption of service plans and the associated speeds. We find that most subscribers, if given the opportunity, naturally migrate to a higher speed if the cost is not a case. And we find also that operators are proactively moving their service plans to higher speeds for a variety of reasons, including competitive pressure. But if in the fourth quarter OVBR report, we look at the adoption of service plans, and these are not necessarily the service plans themselves, but the actual provision speed. So there may be some inconsistencies between the provision speed and service plan offerings. But if we look at provision speeds, the 200 to 400 megabit per second speed plan range is now at 28.5% of the base, and it grew 80% on an annual basis. So that is the trend. We find that some of our customers are also very inquisitive about the impact of the movement of their subscribers into these high-speed plans. For example, what is the impact on a node, capacity on a node, if a certain number of subscribers migrate to the plans, or if they're considering offering higher speed plans as a competitive countermeasure or just a marketing program, a sales program. And because of the insights they were able to pull from the network at a very granular level. So, what's subscribers on a particular node, what are they consuming, what is their behavior, what is the utilization level of a particular node, and then correlating that and being able to model what the potential impact could be of the additional capacity if one of these programs was implemented is very interesting. So that's one of the reasons why we maintain this insight into provision speeds, because it's an indicator of what's to come to operators and how they can potentially mitigate some of the issues, either through using software-based solutions like profile management application or other techniques versus having to spend capital to add additional nodes, do node splits, etc. It's also interesting that the low-speed base, and there are many operators that still offer low-speed packages, and even in the United States, there's now programs to expand access to broadband, where the government subsidizes broadband services to certain segments of the population. And those tend to be lower speed packages. And but in general, there are still some commercial packages that are very low speed, and we find that those are declining. And those for operators are also interesting prospects for upgrade candidates. So, because of all the data that's being collected by our solutions, we can analyze which subscribers are consuming, a notable amount of data that is not typical. So it's atypical for someone in the service plan. So they might be in a 10 megabit per second plan and consuming a terabyte of data, or a large amount of data, which indicates they're probably a good candidate to upgrade to a higher speed plan, assuming that the segment of the network that they're on can handle these incremental subscribers when they adopt the higher speed plan. Or there might be subscribers that are in a 50, 100 megabit per second plan, and they're occasionally reaching the limit of the service offer, the speed offer from their plan, because they're consuming high quality streaming services at a particular time. So because of data, big data and analyzing big data, it's also possible to identify if there are opportunities there for operators to upsell those customers at higher speeds, because it's a clear indication that they have a need for the higher speeds, and they'll probably be better served with the higher speeds, and also could potentially reduce inquiries into the operator about the quality of service, because occasionally they might be reaching the limit of what they can do in their service plan. So the other interesting aspect, and I have covered it a little bit also, is the assumption that someone might go to a higher speed plan and continue to consume the same amount of data, and that is not the case. Through the analysis that we've done, there's a clear linkage in higher speed and higher data consumption, as illustrated here for the downstream side of data, the broadband data service. So we looked at subscribers that consume more than 512 gigabytes versus the ones that consume less than 512 gigabytes and the associated speeds. And it's clear that the ones that consume more data are higher data service plans. And the reason for this is that once they go to the higher speed service plans, there are services that they use, such as Netflix and other video services, that take advantage of the maximum available capacity on the network. So, if they're able to stream 4K, they use the available bandwidth to stream 4K, or they downgrade if it's not available. So as operators open up to higher speed plans, it's likely that the usage will increase in a proportional amount, which continues to introduce issues in the operator's network. And these, again, could be more concerning in the upstream side because of the limited capacity on the upstreams. You know, and some operators, the upstream ratio, downstream to upstream ratio is maybe 10-1. In some cases worse. So there's a lot less capacity on the upstream to offer to subscribers on this shared segment that could be impacted by the additional introduction of the additional services. So this need for speed and profile management application, you know, as I said, as subscribers demand, consume more data, there's a greater demand on the network, both in both directions, but, you know, upstream being the more limited one. As operators migrated from, you know, 2.0 to 3.0 to augment capacity to handle this demand, and now to 3.1. Operators have an opportunity to leverage the capabilities of new DOCSIS capabilities, especially 3.1 and even 4.0 when it's available, to augment capacity in a more passive way without having to introduce more hardware in the network, introduce more node splits, introduce more technicians out in the field to handle all this deployment. And with the added benefit that the PMA application runs in an automated way and continuously to automate the optimization of the network, and also to give operators insight into the other conditions in the network that are not readily visible. But with the data collection and the visibility, they can either take an automated action through, you know, a PMA solution, or they can decide when they want to resolve the situation. So PMA has some interesting aspects. It's probably much more cost effective than doing node splits, and you know, the associated human cost and infrastructure cost. With the added benefit that it runs continuously, because as additional, you know, taps, segments, subscribers are added to the network environment changes, and the only way to mitigate that and to optimize it is to have something that looks at the environment continuously. So what is PMA? PMA was it's a concept that was started by Cable Labs. And you know, it's a natural evolution since Cable Labs defined, you know, the standard for DOCSIS and the functionality available in DOCSIS. So they've also spent time thinking about how to take advantage of all that capability to help operators optimize their network and maximize the capacity of the network. So PMA kind of unlocks capacity in the network that maybe is there, but it's hasn't been taken advantage of because it requires complex analysis of error rates and so on. That's not humanly feasible. Maybe a one-time snapshot it's feasible, but continuously it's not feasible for a human to perform. So PMA is an interesting tool that gives you that kind of capability. And the advantage of it, why it's so relevant at this point, is that it's available across all 3.1 networks and even 4.0 networks, and across, you know, CMTSs, cable modems, you know, anything 3.1 or 4.0 can support PMA. And you know, our experience is that most vendor equipment has the capability to be brought into this world of automation and PMA. So why use it? Why should you use PMA to maximize capacity in DOCSIS? Well, it's to an operator's advantage to maximize the bits per hertz that's available in the network. And you know, as I said, the initial configuration of a network, you know, is important, but the network continuously morphs into different areas, different connections, different points of interconnect, different levels of interference, the coexistence with 5G. In some cases, makes financial sense. In some cases, it might generate interference. So that optimization needs to be ongoing. It needs to be real time because events happen, at that pace. And as operators moved from 3.0 to 3.1, where 3.0 had a sort of fixed capacity, bonded channels, increase the number of bonded channels to gain capacity. 3.1 has now introduced a more dynamic method of handling capacity with lots more bandwidth and a much more dynamic way of allocating bandwidth within the available range. So to maintain all of this is very complicated. The plant's always changing. There's always impairments showing up in the plant that are not easy to detect without continuously analyzing the network at all segments. I'm particularly focused here on sort of the plant side, the 3.1 physical connection side, but it really overall end-to-end monitoring is important from beginning from the user subscribers Wi-Fi environment through the plant, through the access network, and even to the peering network. All of those are very important to monitor and very important to have a single pane view of all that on a per subscriber basis and on a network basis, so that prescriptive actions or remediation actions can be taken either in an automated way or in an alerting way so that the operator can handle them. And PMA, as I mentioned before, has the benefit of creating these virtual node splits. So instead of physically having to split a node, you actually gain this additional bandwidth by applying a software method to the network environment. So you can gain 20–40% capacity back from existing implementation. So without changing any physical infrastructure, cable modems, nodes, CMTSs, by purely optimizing the configuration of the connectivity, you have a significant increase in capacity, which translates to an increase in bits per second and offered speed across the subscribers sharing that bandwidth. So very, very powerful capability that's kind of nascent, hasn't really been leveraged, and is available to all operators who have 3.1 infrastructure in place. And just a little bit more on a couple slides on how this works. So 3.1, essentially you set up the system to collect data from the cable modems and the CMTSs about what is going on in between those two elements through the node, etc. Measure modulation error rates, measure forward error correction variations, and also understand the topology. So which modems are connected to which node, to which CMTS, and then have the ability to correlate all that data and use machine learning to figure out what the best possible configuration should be, modulation should be across all the subcarriers, all the carriers within the off-DMA channel on a very frequent basis. Very frequent could be, every 2 hours, 4 hours, 8 hours. But even, on a daily basis is better than not doing it at all, because the evolution of a network, you cannot just set it and forget it. You can't just deploy it, configure it, and let it go, because there are unplanned situations that can occur. And the only way to detect them is to have a tool in place that monitors continuously and then gives an operator the option to either take an automated action to try to remediate, or at least provide the insight of where the issue is. Could be even a geographically related issue that can be understood through the analytics. So So PMA has that benefit across all 3.1 channels across an entire network. So it not only focuses on a particular segment, a particular node, but it actually performs this across all the segments in the network on a real-time basis. So this little dynamic diagram just is a little bit more of a summary of this process, where the CMTSs and the cable modems both provide insight into the modulation error rates and Fourier correction and topology of the network. That data is collected, analyzed, and then depending on how the operator wants to operate the PMA solution, it can either not take an action in terms of optimizing the profile of the CMTS, and the modulation, etc., or it can be fully automated, or just an alerting mechanism that something is occurring. And the alerting could be hybrid also, where maybe there is an automation process in place where, based on the calculated error rates, the configuration of the profiles is changed, or it could be that that's ongoing, and there's also a learning in terms of other impairments that could be occurring. There could be some LT ingress, there could be other scenarios that are impacting the network, and you gain both benefits. You can see what the configuration optimization is doing, and also what the issue is that might be impacting the service for the particular segment of the network. A more visually interesting way to present the benefit of PMA is to look at the utilization levels on the network. So this chart is sort of a typical, somewhat congested node. What happens at utilization from midnight to midnight, in a sense, where at some points, towards the end of the day, there's higher utilization typically. And something that we've seen also through COVID is the utilization rates that were very low normally early in the day, now have increased, and we surmise that they started to increase even on the upstream because of business activity from home. So work from home, a lot of people now are doing Zoom calls, they're doing Teams, they're WebEx. So there's more and more video conferencing going on, there's more usage of the broadband network than we've seen in prior years. And that has introduced utilization levels that are much higher earlier in the day. But at some point in time, some nodes reach congestion. So they're at 100% congestion, and there aren't many alternatives until PMA, except additional capex, node splits, and so on, to alleviate that situation. I mean, there are other methods that maybe not as popular in some regions of the world, but there's always policy available that can be used to manage congestion. So applying policy, fair traffic kind of management capabilities is an option. The other option is to use PMA to extract this unused bandwidth from the network. So when PMA is deployed, it is able to optimize the bandwidth of each one of the segments of the network, each one of the subcarriers, each one of the OFDMA, OFDM channels, for each one of the modems, for each one of the CMTSs in the network. And with that, it now provides additional capacity to handle the demand at peak period. So as this illustrates, something might have been capped at 100%. Throughout the day now with PMA is able to go past that congestion point. And we've seen that in some cases, and some cases this is real world cases, there's up to 40% capacity gain for an operator. And once you optimize all the segments of the network using PMA. So this particular chart is real world, and in this case, the improvement when measured relative to QAM 256 was pretty significant, 43% on the average. You know, the histogram shows some channels that had more than that in terms of improvement, but an overall average 43% increase in capacity is pretty significant without, you know, requiring any additional hardware or infrastructure or, you know, human touch on the or technicians out in the field trying to optimize the network. So this purely software, purely cloud-based capability that can generate this kind of capacity gain. And you know, the business value of PMA then is the ability to unlock all that, you know, latent capacity that is available on all 3.1 networks. This has the benefit of not only the additional capacity, but it kind of extends the life of the 3.1 investment. So you gain additional bandwidth. You also extend 3.1 equipment over a longer period of time. Maybe during the time where someone is trying to migrate to fiber, perhaps, or waiting for 4.0 equipment to be available, or to avoid CapEx expense, you know, in the current budget year or for a few years, through the use of these virtual node splits. The other sort of indirect benefits are that the marketing sales organizations now may be able to offer higher speed plans. So, you know, with proper analysis, you know, we've seen this with some customers. Some do it well, some don't. Some customers, you know, kind of pre-plan, use our analytics capabilities to decide if they want to venture forward and augment their offering with higher speed plans and what the impact might be on certain segments of the network, if any. Other operators launch these higher speed service plans without actually looking into the potential impact on the network, and then suffer the consequences, which is, you know, impact on quality experience, customer satisfaction. So what PMA does is it kind of opens up additional bandwidth that enables operators to offer higher speed packages, and also reduces the issues on customer satisfaction because now they have additional capacity to play with, you know, additional capacity available on a shared basis. Then the final benefit for PMA is that not only can you augment capacity, is that it also provides insights into what's happening in the network, sort of like a spectrum analyzer for a variety of issues that might be occurring in the network, and it can make those much more intuitive through visualizations. So, an engineer, you know, field tech, someone in operations can use PMA output to understand anything that might be impacting the service on a particular segment of the network, on a particular node, MAC domain, set of subscribers. These things could be, you know, LT ingress, you know, other roll-offs, other impairments that typically remain invisible, or they occur, and this is interesting too, there are some levels of interference that occur on a periodic basis, so they're not there all the time, and unless you're monitoring, you know, at a almost real-time basis, you never see that occurrence. So there could be occasional issues that impact subscribers that is detected and can be exposed through PMA and visualizations. And then my final slide, which is, I apologize for the propaganda, but OpenVault does offer a PMA solution, probably one of the first productized PMA solutions on the market, and you know, with some real world results, and with the benefit that it has, you know, 24/7. If it can be hosted by OpenVault, can be hosted on a private cloud, can be hosted on-prem, whichever way the customer prefers. And we're working with Curio to be one of the first partners in the PMA program that they're introducing. So if you're interested in exploring the potential for PMA and the benefits that it brings, feel free to contact OpenVault, myself, or anyone else. And thank you for the time.
Thank you, Tony. Really interesting. Just, yeah, and some of the questions, there's a couple of questions that have come through, and actually ones I'm quite interested to hear from as well. So yeah, everything's data driven nowadays, so really interesting to see that. So I'm just going to run through the questions, and by all means, if you've covered bits before, just, an opportunity to further elaborate. Obviously, ask for everyone that's in attendance, if you got anything now, by all means, just drop them in the chat or the Q&A function, and we'll get them asked. But I'll kick off with the first one. So we all know that usage has increased, and obviously you've just shown all that and how much by. But has OpenVault been able to give its customers real-time usage and trend analysis?
Yes, so that's one of the benefits that the OpenVault solutions have. They operate both in this closed loop or open loop method. In the open loop method, it's purely analytical output. So we collect the data, and the data that we collect is available to operators for years. So not only can they see very granular down to 15 minutes hourly usage behavior, but they can see what the behavior has been for years for their subscriber base, and use that to pinpoint opportunities to upgrade subscribers, to manage scenarios in the network, so utilization levels in the network, and also areas where they can optimize the network, so through PMA. That is one of the key benefits of being able to ingest big data quantities and analyze, and then provide easy to digest output for operators, so visualizations and results in very pinpointed way.
Awesome, and probably I'll bolt one onto the back end of that. When you have played this data back to operators, have there been any surprises? So if you've been able to give them that extra granular, like you said, data they've had access to for all this time, have any been surprised? You don't have to name operators, but any surprise?
Well, one of the examples that I mentioned where an operator decided to launch a higher speed plan, and there was no coordination between the marketing organization and the engineering organization, so they pushed ahead with the high speed plan, and then suffered the consequences of utilization in the network. If there had been some coordination, and the use of our tools would have helped, where we could see the current utilization of the networks and help them model the potential impact of the launch of these higher speed plans.
Awesome, interesting, thank you. And one other, bear with me on this one, I'll read it through and try and get it right, but by all means clarify if you need to. So this one's from the chat. So given the transient nature of return path ingress and interference, and the high level of resources required to obtain OFDMA subcarrier return MER, typically what recommendations do you have for the timing scheduling of data collection in a real network?
Very good. I'm reading the same question. That's a very relevant question. Yes. So that's one of the balancing acts on PMA. So some of our customers like to do that every 4 hours. It seems to be the cycle that they prefer. But the solution can run hourly, although there's a significant amount of data that is required to be collected, and the issue is not collecting the data and processing the data. The more is it triggering the collection process. So the cable modems need to initiate a collection, sampling, and then pass on that sampling as well as the CMTSs. So there's maybe more of a limitation there, and that equipment doing the sampling and then passing it on to our tool for analysis than the tool actually doing the processing, but it seems to be 4 hours at this point.
Cool. Hopefully that answered a question from the chat. Just seeing another one just dropped through now. Potentially you have. So have you done any analysis on usage due to COVID and more working from home? Yeah,
so the quarterly report, the BBI report, we look at it every 3 months. We also do something that we call data reviews with our customers very frequently, in some cases every month. So, and we try to correlate that with ongoing environments, ongoing occurrences, even things you might not associate. So, here in Europe could be associated with, Premier League football match. In the United States, it could be, the NFL Super Bowl. And we have such granular levels of data that we can associate, traffic usage. We can even look potentially beyond that on what type of applications are being consumed during periods of time, and trying to correlate that. We do find, and we've done this work for some operators, we do find that gaming is getting quite a bit of traction, as is the use of video conferencing during certain times of day. So as I mentioned at the beginning, it is quite surprising to see WebEx, just the traditional, I don't know, no brands, but WebEx, Zoom, Teams, whatever, from say 8 to 11 a.m. Interesting usage. After that, seems everyone goes to lunch and not so much. So, so we're able to correlate, time during COVID and even other behaviors through all the data that we collect.
I'm looking at my calendar now and can see that 8 to 11 trend. Yeah, okay, that's good. I need to change that. No, thank you. That's all from a question point. So thank you very much for fielding those and the presentation. If there's any kind of further, obviously we'll share kind of contact detail, or we'll kind of collect those questions and no doubt can feed them back through to you. But yeah, on behalf of everyone, thank you very much.
Oh, thank you all.